Good morning everyone. Hope you are all good. I hope you are all enjoyed well your personal holidays. Please aware of this. After completing your test or after completing your classwork, come and submit here. And one more thing, whenever you are coming, please ensure you are wearing the mask and you are safety. Okay. So we are dealing the lesson electromagnetic induction and alternating currents. Electromagnetic induction and alternating currents. It's nothing but whenever there is a change in the magnetic flux that induced EMF developed in the conductor, that induced EMF produces induced current. That EMF produces induced current. This phenomenon known as electromagnetic induction. This was discovered by Faraday, Michael Faraday. Okay, who gave this the direction of the lens, direction of the EMF lens. Okay, lens. By direction of the induced current is known by Fleming right-hand rule. Fleming right-hand rule. Okay. So in alternating circuit, what happened to the pure resistor? What happened to the inductor? And what happened to the capacitor when they connected in AC circuit in series? Now, what will happen if the AC circuit containing that resistor, inductor, capacitor in all three in a series? What will happen? Okay. So we're gonna find what is the impedance and we're gonna find what is that total potential. That's nothing but your resistor and inductor and capacitor. Okay, so three is connected with series. So resistor, inductor, capacitor. Listen, the resistors offer resistance. The inductor offer the resistance offered by the inductor. It is called inductive reactance. It is called inductive reactance. Exact. Okay. So the capacitor. The resistance offered by the capacitor is called capacitive reactance. Capacitive reactance XC. Okay. So here we have the potential VR. Here we have the potential VL. Here we have the potential VC. Now the potential difference. Across VR. That means across resistor. VR will be equal to V equal to IR. So VR will be equal to IR. I maximum or IR. The potential difference across inductor VL. I is the maximum current flow through the conductor. And what is the resistance offered by the inductor? Inductive reactance. It is called XL. So XL is nothing but what? XL is nothing but C 1 by L omega. Okay, X is nothing but 1 by C omega. The potential difference across capacitor VC will be equal to IXC. Now we have to draw the phasor diagram for this one. Okay, so we know that for phasor diagram for resistor, the voltage and the current both are in phase. So let in the x-axis we can take this the VR. Let center O will be A, and there must be a voltage leads the current in an inductor by the angle pi by 2. So it will be leads the current. Here capacitor, in case of capacitor, the voltage of the capacitor lags behind the current. Okay, so VC will be here. Now I have to calculate what is the total potential across this circuit. Okay, so let me take the B is the point. Okay, this is A. Here we have to take the total potential. Now the total potential is nothing but what is the range of this one? Range of this one we can take as VL minus VC. Now the total potential OB square will be equal to OA square plus AB square. OAB square will be equal to OA square plus AB square. You can write this one. The x-axis, y-axis, here VR, here VL, here VL, here I have the VR, here I have the VC. Okay, so if you want to take this, you can write this one is nothing but VL minus VC. Okay, so A, OA, OB and OC. Now, OB square will be equal to OA square plus AB square. So, what is the OB square? This is nothing but B square. Okay, B square will be equal to VR square plus BL minus BC the whole square. BL minus BC the whole square. So, the total potential V square will be equal to, or V will be equal to root of VR square VL minus VC the whole square. Now listen, root of, what is the value of VR? It's nothing but your IR, right? So, IR square plus IXL minus IXC the whole square. IXL minus IXC the whole square. Okay, now, then V will be equal to, see, take the I squares common, I squares everywhere is common, so take it outside. I root of R square plus XL minus XC the whole square. So V by I will be equal to Z. It is called V by I is nothing but your resistance, right? So this called Z is nothing but your root of R square plus XL minus XC the whole square. Listen, where V by I will be equal to Z, this is nothing but the resistance offered by the resistor, the resistance offered by the inductor, and the resistance offered by the capacitor. Okay, so all those things are resistance. It's a combination of resistance. When you're taking the phasor diagram for the resistance, it's nothing but this is your Z impedance of the circuit, and this is your R, this is your XL minus XC, and this is your XL, and here this is your XC. That's it. Okay, so this is one of the 5 mark question. Now we have to calculate what is the phase angle. See, what is the phase angle? We have to calculate what is the impedance. Z equal to is impedance of the circuit, which refers the effective opposition of the current by the series RLC circuit. Now, the phasor diagram we have to calculate tan pi. Here, take out the tan pi phasor angle. Always opposite by adjacent. What is the opposite? XL minus XC by R. Pi will be equal to tan inverse of XL minus XC by R. So, here we have the 3 cases when XL is greater than XC. When the XL greater than XC, that means when the inductor, resistance offered by the inductor is greater than resistance offered by the capacitor, then what will happen is that the numerator 2 minus 1 by 1. 2 minus 1 is nothing but what? It's a positive one. So it will become positive, and there is a phase angle. It means that applied voltage leads the current by the angle pi. Okay. Now, suppose XL is lesser than XC. That means 1 minus 2 by 1. 1 minus 2 is nothing but minus 1. So it will become minus, negative. So what will happen here? Here the negative side, therefore current leads the voltage. Current leads the voltage by the angle pi. Suppose XL will be equal to XC. Then what will happen? Then there is a 0. It will become 0. The phase angle will be 0. There both are in phase. Both are in phase because there is only one resistance will happen, but resistor. So these will be equal. So it will become 0. So and the current and the voltage will be in phase. Will be in phase. So next one thing. What is called resonance? What is called resonance? Or what is meant by the Q factor? Or what is meant by the resonance of the circuit? Resonance of the circuit is nothing but when the frequency applied to the alternating source is equal to the natural frequency in an RLC circuit, the current in the circuit reaches the maximum value, then the circuit is said to be electrical resonance. The frequency is called resonating frequency. Now listen, frequency 1 by, we know that omega equal to 2 pi f. So f is equal to omega by 2 pi. What is the omega? Omega is nothing but 1 by root LC. So 1 by 2 pi root LC. Okay, 1 by 2 pi root LC. Now, whenever so 2 pi f will be equal to 2 pi f is nothing but what? Whenever omega the resistance offered by the inductor which will be equal to resistance offered by the capacitor. L omega will be equal to 1 by C omega. Then what is it, this one? L omega by the resistance offered by the inductor will be equal to resistance offered by the capacitor. What the maximum resistance at this condition, the resonance in the RLC will be takes place at this condition, because all the alternating voltage, all the resistance will be, see, the impedance will be equal to root of R square plus XL minus XC the whole square. So when these two things are equal, then it will become 0. The maximum current will be equal to R. Then the resistance only offered by the resistance of resistor. So the maximum current will be flow. So the maximum, when the maximum current flow through the circuit, it gives the maximum resonance. It gives the maximum resonance. Okay. When you are tuning the when you are tuning the radio TV circuits, you may see 90.6. 94.6 or 92.1 whatever may be. Okay. So all the frequencies are having the nature. Okay, naturally they will occur. When you are having the radio box on your home, there must be a one tuning. This is volume, let me. This is a tuning cup. Okay, regulator. When you are tuning this one, what you have to do, you are making the capacitor. Okay, you are making the capacitor which is offered the resistance. The resistance offered by the capacitor, which will be equal to the resistance offered by the inductor. It happens only in the RLC circuit. Okay, it happens only in the RLC circuit. When you are tuning this, that means when you are adjusting the resistance of the capacitor, which is provided, will be equal to the inductor resistance. Okay. The inductive reactance XL, which will be equal to that capacitor, then there is it will become 0. Then there is a maximum current flow. So it is approach that particular value of frequency. It approach the particular acceptance of the circuit. Okay. So next one thing, Q factor or quality factor. What is the Q factor or quality factor? The Q factor or quality factor is nothing but voltage across inductor or capacitor by applied voltage. Right? Applied voltage. So this one we call as Q factor. What is the use of Q factor? To see or to determine the acceptance level or the sharpness of the radio. Okay. So listen. Next one thing, there must be a power in AC circuit. What is the power formula? Power is nothing but P equal to VA. P equal to VA. So V is nothing but Vm sin omega t. I will be equal to Im sin omega t. So power equal to VA. Power average. We have to calculate what is the power average. Power average will be equal to Vm sin omega t plus sin I equal to Im omega t. Applied voltage is always same whenever you are applying to the AC circuit. But current it is not same. For the current, in case of resistor, I equal to Im sin omega t. In case of inductor, I will be equal to Im sin omega t minus pi by 2. In case of capacitor, I will be equal to Im sin omega t plus pi by 2. So there must be a phase angle difference. Okay, so plus or minus. What will we do? Then when you are writing that I equal to Im sin omega t plus pi. Omega t plus pi. Okay, there must be a phase angle changes. So you have to write that one. So Im sin omega t plus pi. Sin A plus B form. Okay, Pm Im, take it outside. Vm Im sin omega t. So when you are taking the sin omega t plus pi, you have to take cos t. Sin A cos B plus cos A sin B. Okay, sin A plus B form. So sin A cos B plus cos A sin B. Okay, multiply this one. Vm Im sin. So sin squared omega t cos pi plus sin theta cos theta. Okay, so cos omega t sin pi sin omega t. Now cos theta sin theta is always 0 because cos 90 will be 0. sin 90 will be 0 or sin 0 will be 0. So whatever you terms you are putting here, it will become 0. Sin theta cos theta always 0. So sin square omega t, it's make a value, whenever you are doing the sin component, it's make a value of 1 by 2. So I can write Vm Im 1 by 2 cos phi. Or I can write Vm, we can write this 2 equal to root 2 into root 2. Right? So I can write Vm by root 2, Im by root 2 cos phi. Or I can write Vm by maximum voltage by root 2. Maximum voltage or maximum current by root 2 is nothing but your Vrms value, right? So Vrms, Irms cos phi. So what is the power average in the circuit? The power average is nothing but Vrms, Irms cos phi. Vrms, Irms cos phi. So here the Vrms, Irms is called apparent power and the cos phi is called power factor. Cos phi is called power factor. The average power of an AC circuit is always known as the true power of the circuit. True power of the circuit. Say, now the phase angle between the voltage and current is equal to 0. That means whenever there is the pure resistor case, there is both are in phase, what will happen? So cos phi will be equal to 1. So power average will be equal to Vrms and Irms. When the purely inductive or capacitive, that means the second case when purely resistive. Phase angle cos phi will be equal to 1. Then it will become P equal to Vrms, Irms. When purely inductive or capacitive, plus or minus pi by 2. Whether it is inductive, minus pi by 2. Whether it is a capacitive, it is going to be plus pi by 2. So what will happen? There must be a phase angle. So cos pi by 2. That means cos 90 will be equal to 0. So power average will be equal to 0. Power average will be equal to 0. So in case of XL will be equal to XC. In the case of RLC circuit, what will happen? When there is no phase angle, then it will become P equal to Vrms, Irms. Okay, that's it. Here we have the one more component Vrms and Irms. There must be a phase angle Vrms and Irms cos phi. The component of the current Irms cos phi, which is in phase, the voltage is called active component. Okay, both are at in phase. Both are at in phase. That means Irms cos phi, the active voltage and the current are in phase. Then it is called active component. The power consumed by this circuit, is called Irms, Vrms cos phi. Irms, Vrms cos phi. So this one we call watt-full current. This one we call watt-full current. When the other component Irms sin phi, which has the phase angle, when they have the phase angle of pi by 2. When the phase angle of pi by 2, the voltage or current leads are lagging behind one of each other, then that should be make an angle of pi by 2. That voltage is appeared to be pi by 2, then the voltage is called reactive component. Then the power consumed by this component will be equal to 0. Power consumed by this value equal to 0. So this one we known as wattless current. This one we known as wattless current. The current in the AC circuit is said to be wattless if the power consumed by it is 0. The wattless current occurs with purely inductive or capacitive. When the RLC circuit has the only inductive or capacitive, then only it will happen. Otherwise, it will become P equal to Vrms, Irms cos phi. P equal to Vrms, Irms cos phi. Okay. Okay, tell me, what is the advantages of the AC than moving DC? Okay, what are the advantages of AC current or what are the disadvantages of AC current over the DC? There are many advantages. The first one, the alternating current is cheaper. Okay, the alternating current is cheaper than the DC one. Cheaper than the DC one. When AC is supplied to the at higher voltage, the transmission losses are small compared to DC. Okay, the first one, cheaper than DC, transmission loss is less. Okay, transmission loss is less, and for production, for easily converted into DC, AC can be easily converted into DC with the help of the rectifier. So you can convert that. Converting is easy. Okay, so these are the advantages. What is the disadvantages? Alternate voltage cannot be used for certain applications such as charging the batteries, that means which one needed the DC voltage, and electroplating and electrotraction. The high voltage is always, always the alternating current is more dangerous than the DC. More dangerous than the DC. Okay. Oscillations in a AC cycle. Next one is very important thing. Okay. So what is mean by oscillations? So you know that damped oscillations, undamped oscillations, and then resonance frequency, right? You know that resonance. Here we are going to see that what is the LC oscillations. What will happen? Simple. You may know that oscillations of simple pendulum also. Now, oscillations happens during the L and C. What is mean by L and C here? It is not a letter. It is a purely inductive and purely capacitive. Nothing but your inductor and capacitor, when they are connected in series, they produce this tank circuit. It's called tank circuit. See, I have that capacitor here and I have the inductor. Okay, so first this one we called as tank circuit to maintaining that. What is the uses of the water tank now? Nowadays, you just tell me and think about it. What are you doing that one with the water tank? We store the water. Again, we are using the water. Again, we are fill the water tank. Again, we are using. So whenever it's discharged, whenever it decreases, we are filled with again and again. Same things will happen. Whenever the charges are discharged, again it will refill. Again it will discharge. Again it will refill with electrical energy and magnetic energy. Electrical energy and magnetic energy, like that. Okay. So vice versa. This is called one of the tank circuit, which is used for the oscillation purpose, LC oscillations and then sinusoidal oscillations there. Remember that is called in 9% we will see that one. Okay. So such oscillations, we are maintaining that oscillation with some external force also. Some of the oscillations will maintain with the what is that? Damped forces. Okay. Damped forces, you know, right? Whenever there is a peak value of amplitude, when it goes there, the time variation, it will become continuous and then stop at one time. Okay. It is called damped oscillations. So to maintain undamped oscillations also, we are no. Now listen. First, the capacitor. Here I have the positive charges. Here I have the negative charges. Okay. It's filled with that. Capacitor charges are filled. Once the charge is stored fully, what will happen? Always the charge is fully in the capacitor, fully charged by the capacitor. Always the charges will be leaked from the higher potential to the lower potential. So whenever the charge, so first things is fully electrical. When there is a current will be equal to 0. Electrical, they have only that electrical energy. Whenever the current flow through the circuit, what will happen? Whenever the current flow through the circuit, all the charges will be equal. So the positive charge will be goes to higher potential and negative charge will be the lower potential. It will be leave. Whenever the current flow through the inductor, what will happen? It creates both. It's also the current will be flow. Whenever the current flow through the inductor, it creates the magnetic field around the current conductor. So here, what is the energy? The total energy will be equal to magnetic energy plus electrical energy. Then the third stage, what will happen? The full energy, okay, the full charges will be leaving the current flow through the inductor. It creates the total magnetic energy. Totally, it will become converted into magnetic energy. Here, there is no current charges. So all the charges are leaving and it is converted. It goes into the current, goes as a current, and then it will become magnetic energy. So here, whenever the current flow through the inductor, there will be a magnetic field around the current conductor. So the whole energy will be equal to the magnetic energy. So wholly it will become magnetic energy. So what will happen? Now, at the fourth stage, whenever the current flow through the inductor, there is a magnetic field. Whenever the magnetic field, when the current is increasing the level, magnetic field lines are also increases. Whenever there is a changes in the magnetic field lines, they must produce as induced current. That current is opposes the charges and always opposite in the direction. So all the positive charges will be accumulated in this direction and negative charges will be accumulated on opposite direction. So the current will be flow. So induced current EMF will be developed. That EMF will be stored as a charges in this capacitor like that in the opposite direction. Again, once all the charges will be stored like a positive charges here and negative charges will be here. Whole it will become electrical. Again, what will happen? Again, whole positive charges will be here and negative charges will be here. Current will be goes in this direction. So again, it will become magnetic field, and the magnetic field, that is magnetic field lines are changes. So magnetic flux changes. So that induced EMF produces, that induced EMF develop induced current in opposite ways. So it will become positive and it will become negative. So this is how the charges, that energy will be converted, electric energy converted into magnetic energy. That magnetic energy again is converted into electrical energy. This is how it works on, and one up to the damped oscillation. So we can make it out to undamped oscillations also. And one more thing, remember that these charges can produce, this is one of the best example for producing the energy, law of conservation of energy. Law of conservation of energy. There will be two types. One is the called conservation of energy in the LC acceleration. Total energy. Total energy is nothing but what? Total energy U. Total energy U will be equal to electrical energy plus magnetic energy. So we know that Q squared by 2C. Here we know that 1 by 2 Li squared. 1 by 2 Li squared. So in the case of when the charge is the capacitor Q equal to Qm, the current through the inductor I equal to 0. First case I equal to 0. What will happen? The total energy will be electrical. Total energy will be electrical. So electrical energy plus magnetic energy. So here I will be equal to 0. That's only the charge is only electrical. Then we what will happen? So Q squared by 2C plus 0. The total it will become electrical. When there must be a when the charge equal to 0, current will be flow through the conductor. Current will be flow through the conductor. When the Q equal to 0, when Q equal to 0, so this term will be 0, and here we will get half Li square. Half Li square. Maximum current flow through the circuit. Maximum current flow through the circuit. So here also we can write Im will be equal to I will be equal to Q squared by LC. Q squared by LC. Okay, because I is the rate of change of charges, right? In case of 3, when the charge Q and current I, the total energy. So both will be acting. Charge Q and current I. Then it will become Q squared by 2C. R you know, right? Qm squared, maximum charges by 2C plus half L I maximum. Okay, that's it. So this is how we have right. What is the qualitative treatment? Qualitative treatment is not quantitative treatment will be there. Qualitative treatment is comparing this energy, electrical, LC oscillator energy with the mechanical spring mass system. Spring mass system. Okay, remember that. What will happen? The analogy is between the electrical and mechanical quantities. There is an electrical system. In an electrical system, we have the charge. We have the charge Q. Okay. In a mechanical system, we have the displacement X. We have the displacement X. Now, charge I. What is the I? Current. Current is nothing but rate of flow of charges. Rate of flow of charges in a particular time. What is the velocity here? The velocity is nothing but rate of change of displacement. Rate of change of displacement. Okay. So here, what is the here inductance RL? Okay, inductance or inductance. Inductance is called here because this is the magnitude. Only here the magnitude. Then here I have the mass. Here I have the mass M. Here I have the mass M. Here the electrical energy Q squared by 2C. Here I have a potential energy, right? Okay, Q squared by 2C is the my electrical energy. Here I have K by 2 X squared, right? K squared by 2. It is my potential energy. Here electrical energy, here potential energy. Here the magnetic, whole magnetic energy. The magnetic energy is nothing but 1 by 2 Li squared. Here I have the kinetic energy 1 by 2 mv squared. Next one, electromagnetic energy. Both energy will be compared. So electromagnetic energy is nothing but 1 by 2 q square by c plus li square. 1 by 2 is common, take it outside. Here we have both energies, so 1 by 2 take it outside. So what is the energy will be there? Kx square plus mv square. That's it. Okay, so alhamdulillah we finished this lesson. Here I have the duty to finish and complete the lessons, and also I want to improve your knowledge. Okay, that's it. See, please ensure that you are aware of these lessons, and then please make sure you are understanding all the concepts of these lessons. After that, you just realize that your knowledge of these lessons, and then just clarify with the doubts with that your seniors, or maybe to me, or your neighbors, teachers, or whoever may be there. Okay, so listen once again, read well, write well. Whenever I am giving the test, please write well. Okay, thank you guys. Allah Hafiz.